Good morning to all. In this video, we are going to continue CDC Solutions Designs, and we are taking as a handshake-based pulse synchronizer today. So we already know there is a asynchronous domains may be present in our designs or systems, and if you want to send some data or signals from one domain to another, which is asynchronous in the nature, in that case there will be some metastability cases or conditions. To mitigate that things, we need some standard solution to have that communication in between these domains. So starting with the already seen my earlier videos for the CDC solutions and regarding VCS and the that design vision, so that we can have this useful information to understand. Okay, so taking the reference of the toggle flow synchronizer, we already saw that we can send the pulse from one domain to another easily with we can say that without feedback, and the constraint is that to have that repetition, at least we have to 3 or 4 clocks additional duration in between these pulses with respect to the destination domain clock period. So just if you imagine this diagram or same design we can use for the feedback also, called handshake signal. Just in this diagram, actually these are the things are almost similar. We take the feedback from the receiver side. There is one busy signal is created. From the waveform we can say, let's say signal is high, and as soon as it goes high, the busy signal will protect for the further signal transactions. So once the receiver side get the pulse, it will acknowledge as a busy low, and then again we can send another pulse like that. So in more detail, let's say there is a signal 1. Once the clock arrive, we get the 1 here. Assume that all the clocks are at reset condition initially. So once we get the signal edge, we have the busy 1. In the next clock cycle, if the signal goes to low, so obvious the feedback that is going to here is make it logical 1 here always. So in the preceding clocks, what happened, the 1 get populated at the output. Okay, and as well as we get 1 here, we arrive 1 here also. Still in next clock the output goes to low and still busy equal to 1. Proceeding cases or proceeding next cycle, we can say the value of this box selected goes to 1, so the 0 is populated in this path, and after some clocks we get busy equal to 0, and then we can have the acknowledge to the sender side, then it can be sent another pulse here. Okay, in this way it works actually. So for this simulation setup and the synthesis setup, we are taking the benefit of the VCS and the design vision. First we go manually, like these are the code location in under the top. I am generalizing that the top, whatever we consider in further, we took this as a top name. I mean to say that whatever the name of that design, it will come under the top, so that the whatever the setup I discuss here, it is compatible to the all others in further videos. Okay, so there will be the one module as a top, there is a test bench for the module. Okay, and what are the file list, we already seen, we kept all the paths in all files.txt, so it will be the top tb top, and then we have the command make top equal to the name of the test bench top. This is for the RTL, so we are referring this top under the code folder. It is a RTL code. Once we synthesize this top, it becomes the get netlist top. So for the synthesis, what it changed, basically only the location of the code get changed, and we take the one additional reference from the library. So after the design vision, it will be under the result DC90 top90.v, and the rest of the test bench is same. So only the change in this file list, in place of the RTL path, we take the synthesize netlist path, and the command is same for the VCS synthesis simulation as well. So I just come across these two things get complicated in two ways, because it has separate file list and the file locations. So I just unified the process of this VCS for the simulation on the basis of synthesis or RTL. So I just kept one small code inside the Makefile. We will see what Makefile has some updation. So there is one mode, let's say, has RTL or synthesis. So on the basis of that, we took the path from the either RTL location or synthesize locations. Okay, the test bench is common. So the file list will be in a similar way. If RTL we are providing, then the path of the RTL we take, else we take the synthesize path. So the additional command has mode equals to RTL or synthesis. Okay, so this is smaller change and update in the Makefile. So for the design vision, so the setup is same. Okay, because in design file, design vision, what we are doing, actually there is a tickle file. Under that we have to manually give the top level name. So in spite of giving the or editing the design visual tickle file, so I just update that tickle file so that we can give the top level name from the command itself. We took the benefit of x -x, and these are the command like set my top level HS pulse synchronizer. Okay, so the tickle file will be intact afterwards, because we are taking the benefit of this command. So we provide the top level name, so there is no need to edit manually on the tickle file of the design vision. So moving to the process, we, as you know, we go through the code first, then all file list, that is file list, and then we go for the Makefile, then design visions or tickle file, and then we see the waveforms on the RTL basis or synthesis basis. So we try our best to summarize this in minimum time, but still it takes almost 15 to 16 minutes. So we go with the first the code. Okay, under the command, from that we check all the codes. Code HS, this is our main top. So according to the whatever it is based on the same thing. Okay, we take the synchronous reset. You can pause and you can record whatever you want. Okay, we move to the test bench. So these are the two clocks with the different periods. We are taking three repetition of the pulse along with the wait command for the busy. This is an instance of the main, and we are taking the dump.vcd files for the same. Okay, anyway, moving to the file list. So file list will be all. So okay, .txt. So file list, these are not important. So in this file there is nothing active except the tbhs. It is only test bench file I have kept here. Otherwise it is nothing active anything here. Okay. either you can have the Control V, select, and even though we can delete this, Shift V, like this. Okay, so there is nothing in this file list. We are take only the test bench and the reference file, but it is required only for the synthesis process of simulation. So you can consider only the test bench is in this file list. Okay, we're moving to the this is our codes and file list. We are moving to the Makefile. Just overview the Makefile. These are the some changes in this Makefile with respect to the other videos. I take one more variable here. Default is RTL, file list, temp file list, and just I check whether the user provides the RTL or not, or mode or not, like RTL or synth. If RTL is there, we use one path that is from this code as our top level module, or either from the synthesis location, that is results DC top clean 90.v. okay, if we are not providing, means we have to provide, or it will give error like this one. Okay, and one generate file list is a one pony is there, which take the SDL path files, okay, and give it to the temp list or temp file list, and then again file list append with this temp list. So according to SDL files from this this tiny code of if else, either we give the RTL or the synthesis net list, we can append this with the whatever the exist our file list has, that is all.txt. So it will simplify the process for the simulation and run actually. So I hope you got this tiny changes, otherwise the rest of the thing is same. Okay, please refer my earlier videos so you can get the quite understanding of this Makefile. So to run this, we have as our command is make top, then this is make top is our test bench model name. This is for RTL, just click it. So might be further the videos may be little bit faster for the explanation, so please refer whatever I submitted in earlier videos, so you will get that things. Okay, so under this you can find this is a duck, and if you click the duck, it is a RTL code. Okay, and just you have select all, Control A, Control 4, it will pop up the waveform window, and just hit the F5, then fit using the F. Okay, this is our signal that we need to transfer. This is output signal, and this is a busy signal. So as soon as the pulse arrives, the busy goes high and we get the receiver side pulse. Okay, and this will continue according to the cases. When the busy goes low, it will again send the data or pulse, then we again receive the signal likewise. Okay, so we are checking for the slow to fast. Basically clock 1 is our source destination, source clock, and this is clock 2 is our the receiving domain. So even though we have these things, it will work for the both the things. So we can just go back to the test bench and change the timing of the pulses. So we kept press I for the insert 5, 50, 300, and then at difference 100, and then we can keep the signal pulse width like 450. Okay, just save and execute. Right, then again go back to the real. We will see if we change the slow to fast, fast to slow, what will happen. So just select all, Control 4, F5, fit. In this case also, if this is a signal and this is busy and this is our clock, is a fast one. Okay, so the signal still Okay, there is one uncertainty in this due to the reset. Okay, because it is a synchronous reset and we will not get the proper rising edge up to that value. So we back to our test bench code and make it happen like that. So okay, the reset, okay, this is the reset. So if it is 300 is on time, we have to at least 600 for the same. Okay, let me save and execute. Once we check, it is not having the. Okay, this execute. So it might be a little bit faster than the earlier codes or videos. You just keep watching what I'm doing. Control A, Control 4, hit F5, zoom fit. Okay, zoom fit. I don't know why it is not running. I just resimulate first. Okay. Control A, Control 4, then F5, then zoom fit. Okay, so as we saw, the reset is active properly there. So this is our fast, slow, this is our signal, this is our busy, and this is our received pulse. So as we saw, this is signal busy, then received, again it goes low, add a busy, again send a pulse, again go high, then we receive the signal. So in this way we have both vice versa, receiving or sending the data from one to another with a high slow clock domains. This is RTL simulation. We go for the synthesis simulations. So keep in mind that we are providing this as a RTL or like synth. So even though we know that there is already synthesized get netlist present in this design, so still we go back to the design vision. This is 90. Check the tickle file. Okay, this is tickle file I create for this module. The change is that in this we are taking the top level from the external command. Like within a command we are using the top value and we are using that top, okay, as a further my top levels. So in further cases we don't need to edit this tickle file. Still you can overview these things. One additional point I create here is that one extract timing tickle I created under this, so that it will help for the see the slacks on this setup and violations, even though it print on the console itself. So it will benefit without going inside the reports. Okay, so this RTL, additionally this extraction time tickle I will show you. The rest of the thing is same as to our earlier videos. Okay, quickly give the overview of that tickle extract RTL. Whatever the tickle file you create, no? So original main tickle file create all reports under this results. This is 90 and report all 90 and timing extraction. I just add one report there, which will extract the whatever the times in main report. Okay, it will catch up the maximum minimum for one path from the report all 90.txt. okay, and give the slacks value, everything. Like, okay, so back to the, so we can have the run of this from the work folder. So as we saw, the in the this is command we have to give. So in spite of going to the graphical things, I just use the command line commands, so it will quickly run that. So as I saw, it will pop up the all.txt report. It is for the area. Okay, this is for power. Mainly the switching power is important, so it is very tiny. This is for setup violations for maximum path 1. So these are the timing flags. This is for hold. So even though we after that tickle run, we get the print on this as well. So it will help for the without going into the opening of that txt files. Anyway, we're moving to the simulation part of the synthesis report. We already know the our result is in this in 90. Then obvious the result is 90.v. This is our get netlist for this. And one additional thing I did, I add time scale 1 nano per 100 pico using the tickle file itself. Okay, so there is no need to go inside this and change that things. It is in the DC. Okay, DC 90. So I just make sure that it will add one timing line in this get netlist. So this is the code for that. It will automize the things for the get netlist to add that time scale line. Okay, so moving to the okay, we have not seen the this is command for the run in the shell window. So I just over with the schematic and the that symbol. So once it is completed, you just type the command like start GUI. That you just select it, it will give the schematic. Okay, zoom fit. This is schematic and this is for symbol. 2 clocks are signal in, signal out, busy. Okay, I hope you got this. Moving to the VCS folder, so that we can have the command like make top mode synth. Okay, under this you go to the synth. So it will atomize the things for the synthesis. You already saw these things. It is taking the proper path for the, this is our synthesis get netlist, this is test bench, and this is for the reference design name for the 90 nanometer. Okay, under this you can check also the duck is not the original one that we already saw. It is a get netlist based duck. So I hope you got the points. Control A, Control 4, F5, zoom fit. Okay, okay, I think I just little bit faster than this one. We simulate one more time, but Control A, Control 4, hit F5, then fit. Okay, so this is the original signal, this is the output signal, this is a busy signal, these are the 2 clocks. This is a fast to slow domain, so from that it's clear that it works properly, even though after the post synthesis. So even if it is working on the fast to slow, obviously it will work for the slow to fast. So I don't think that it necessary to go with the test batch change and validate the things. So I hope you got the point, and thank you for watching, and keep stay with me. Thanks, and please hit like button, subscribe, it will motivate. Okay, thanks, bye.